my dear students, we can see here question number 19. Aqueous solution of ammonia consists of. This question is also asked in 1991 NEET exam. So we can see a reaction. Here, my dear students, when we can see this reaction, when this ammonia gas is dissolved in water to form NH4OH ions. Here this NH4OH ions is decomposed into OH plus and OH minus and NH4 plus ions. So my dear students, when ammonia present in aqueous solution, then it contains ammonium ions and OH minus ions, because water molecule reacts with this ammonia to form ammonium hydroxides. So in urea you can see here NH2CO, NH2 dissolved in water to form ammonium cations. And when these ammonium cations are heated, it is decomposed and this ammonia is liberated. So my dear student, this is the concept and reaction. Aqueous solution of ammonia consists ammonium ions and OH minus ions. So you can go the question number 19, D option is the correct option, my dear students. Now we can go to the question number 20. Here, my dear students, question number 20, you can see which of the following oxides of nitrogen is paramagnetic. Here, my dear students, we can apply the MOT theory, and because it's a heteroatomic molecules. Here, nitrogen get valence electron, that is nitrogen, you can get 7 atomic number, 2 and 5, and oxygen atomic number is 8, 2 and 6. Here 2 oxygen atom is present, so it's multiplied by 2, that equal to 12, 12 plus 5, that equal to 17. My dear student, this is a trick to calculate the paramagnetic nature or diamagnetic nature. Now we can, this is the NO2 molecule first. Now we can see the N2O. Here nitrogen get the 5 valence electrons, so 2 into 5 for nitrogen, and plus for oxygen you can get the 6 for oxygen. So you can get the 16 electrons total. Here total is a 17 electrons. We can see here N2O3. My dear students, when we can see the N2O3, 2 into 5 valence electron for nitrogen plus 6 into 3 electrons for oxygen. You can get 10 for nitrogen and 18 for oxygen. So total number of electrons is 28. Now we can see the N2O5. Here, my dear students, nitrogen get 5 valence electron, 2 into 5 for nitrogen, plus here 5 into 6 for oxygen. So you can get this here 5 to the 10 for nitrogen plus 30 for oxygen. So you have total number of electrons are 40 for N2O5. Valence electron, these are also valence electrons. We are calculated only valence electrons. My dear students, trick is that when you can see the even number of valence electrons, or you can see the even number of total valence electrons. Even number of total valence electrons, then my dear student, it's a diamagnetic. Molecule is a diamagnetic. Molecule is a diamagnetic molecule. And when, my dear students, odd number of total valence electrons are present, then my dear students, it's a molecule is a paramagnetic nature. or paramagnetic molecule is present. So you can see here which molecules is diamagnetic and which is paramagnetic. You can find out easily. Here NO2 17 electrons present, my dear students. Here you can see N2O 16 electrons are present. Here you can see N2O3 28 electrons are present, valence electrons. And you can see the N2O5, here 40 valence electrons are present. So my dear students, here odd number of electrons are present, only one molecule, that is NO2. So my dear students, this molecule is a paramagnetic nature and this is trick. You can also call it, this is Avasthi trick. Now we can see the question number 21. Which of the following is a nitric acid anhydride? You can also calculate it anhydride by small trick. I am giving to you. Here my dear students, nitric acid, formula of nitric acid is HNO3. First of you write molecular formula and remove the water molecules. Here my dear students, H2 is not removed, so you can twice H here, H2 is removed and you can get the N2O5. So my dear students, you can get the N2O5 nitrogen pentoxide. Why? Because we can remove the water molecule from this nitric acid. So oxide of this nitric acid is called anhydride, because this oxide is formed when water molecule is removed. So it is called anhydride of nitric acid. My dear students, in this way you can get the anhydride. Now we can take the other example which is not given in your question, but I give you. What is the anhydride of nitrous acid? My dear students, first of all you multiply by 2 because water molecule, 2 hydrogen atoms are present. So H2O is removed, and when this H2 is removed, my dear students, you can get here N2 and 2 2s are 4. One oxygen atom is replaced, that's why you can get the O3. My dear students, it's a anhydride of nitrous acid. This is the anhydride of nitrous acid. In this way you can get the anhydrides. So here question is that nitric acid anhydride, it is N2O5. We can go the answer C, question number 21. Now my dear students, we can see the question number 22. When copper is heated with constant HNO3, it produces. It's a very easy question, my dear students, and you know the reaction. I give you further reaction. This copper reacts with HNO3. It is a concentrate to form copper nitrate plus NO2, copper nitrate plus NO2 plus water. So my dear students, you always learn copper nitrate, metal nitrate is formed, and second one is NO2. NO2 is obtained when constant HNO3 are used. So this reaction is an important reaction for you. You always remember that reaction. Constant HNO3 is reacts with copper to form NO2 gas. So my dear students, when you can see the question number 22, answer is C, because NO2 is present in answer C. My dear students, in presence of constant HNO3, you cannot get this NO with NO2. So this is not answer. Please see it. Now my dear students, we can go to the question number 23. Here my dear students, zinc gives hydrogen gas with H2SO4 and HCl, but not with HNO3, because zinc is not evolved HNO3, because HNO3 oxide layer is deposited on the zinc surface. Here you can say zinc, and when this HNO3 is reacts with zinc, then oxide layer is deposited on the zinc, and this oxide layer is called ZNO. When this oxide layer is deposited, then nitrate ions of the nitric acid is reduced in preference to hydronium ion. So, my dear students, you can go the answer D. Question number 23, answer is D. This question is also asked in 2002. Now, my dear students, we can see here question number 24, sugarcane on reaction with nitric acid. Here, my dear students, if you know reaction, then you can solve this question. Sugarcane means sucrose. Molecular formula of sucrose is C12H22O11. And when this compound reacts with HNO3, it is a concentrate. All carbon atoms which are present in as a ring structure, here two types of ring structure are present, glucose, because glucose and fructose are present in sugarcane. So, my dear student, glucose structure is called glucopyranose and fructose structure is called fructofernose. Both are cyclic structure present in this. So, my dear students, all the carbon atoms are decomposed, and to get this oxalic acid, COOH and COOH, you can get 6 molecules of this because here C12 are present, and all the hydrogen and oxygen are liberated by water molecule. So, my dear students, here you can see the reaction. By this reaction, you can get this compound is called, my dear students, oxalic acid. This is called oxalic acid. So, you can go the answer B. B is the oxalic acid. Now, my dear students, we can go the question number 25. Which of the following phosphorus is the most reactive? We can see here, number 1 concept is that white phosphorus is more reactive than red phosphorus. Red phosphorus more active than the scarlet phosphorus, and scarlet phosphorus is more active than violet phosphorus. In this way, my dear students, but white and red phosphorus are important. So, nowadays we can get this type only question on white and red phosphorus, but these are the reactivity. So, you can go the answer B. Now, my dear students, we can see the question number 26. Each of the following is true for white and red phosphorus except that they. My dear students, white phosphorus and red phosphorus are dissolved, both are dissolved in carbon disulfide. So, it is a basic question. My dear students, white and red phosphorus oxidized by heating in air consist of the same kind of atoms, means phosphorus can be converted to one to another form. So, answer is A. Here white phosphorus are both soluble in CS2. This is the exception because here question is that except when this B answer you can see can be oxidized by heating in air. Yes, both are found P2O5 or P2O3. When you can see the option B consists of the same kind of atoms. Yes, phosphorus atoms are present. When you see the option D can be converted to one another. Yes, white phosphorus, when white phosphorus is heated, it is converted to red phosphorus and vice versa. White and red color is depends on the temperature. So, we can distinguish between white and red phosphorus, both are not soluble in carbon disulfide. And so, these both are soluble in carbon disulfide? No, not at all. So, answer 26 option is A. Now, my dear students, we can go to the question number 27. A compound acts upon reaction with water produces a color gas. So, you can put the reaction. A compound X. Here X is the compound, my dear students, and reacts with water. To give a Y colorless gas. and this white colorless gas is a rotten fish smell. This white colorless gas absorb copper sulfate solution to form Cu3P2. As one of the products predict the X. We can find out this X. Now, my dear students, we can see the question. Here, when you can get the Ca3P2, because this reaction is also seen in a book or given in your book, Ca3P2 calcium phosphate, when reacts with this water molecule, this PS3 gas is born, my dear student, phosphine gas, plus thrice COH whole twice are obtained as a byproduct. This phosphine gas, my dear students, when reacts with copper sulfate to form Cu3P2 plus H2SO4 is evolved sulfuric acid. So, my dear students, you can see here answer this X is the Ca3P2. So, you can go the option A for question number 27. Now, here my dear students, we can see the question number 28. When this phosphonium iodide plus NaOH, both are reacts with each other. Now, my dear students, you can see the reaction. Here this is the phosphonium pH4 and I, iodide minus ions. Reacts with this NaOH alkali. Here plus and minus are present. You can see here sodium iodide is this sodium iodide. You can get the sodium iodide is present, and pH4H plus ions give 2OH to form water, and this PS3 is evolved. This is phosphine gas. So, my dear students, you can get this phosphine gas PS3. Now, we can see the question number 29. Here, my dear students, question number 29 is asked in NEET 2019. Identify the incorrect statement. Minutely you can observe incorrect statement related to PCl5 from the following. Here, my dear students, 3 equatorial, B option is the 3 equatorial PCl bonds make an angle of 120 with each other. Yes, because about this B option, phosphorus attached with these 3 Cl bonds, and these are called equatorial bonds, and these bonds are called axial bonds, and angle is, my dear student, that is 120 degree. So, these equatorial bonds are present on 120 degree angle with each other. Now, we can see here C option. C option tell us 2 axial PCl bonds. Yes, this is the axial bond, my dear students. This is the axial bond. Two axial bonds, PCl axial bonds, make an angle of 180 degree. Yes, this is axial and this is axial, and make a 180 degree with each other. So, C is the correct answer. Now, we can go to the D option. Axial PCl bond, this is axial PCl bond, are longer than equatorial PCl bond. Yes, this is also correct, because you can see this is the longer and this is smaller. So, my dear students, incorrect answer is A. Only A is the incorrect answer. PCl5 molecule is non-reactive. This question is asked in NEET 2019, my dear students, question number 29. Now, we can discuss here question number 30. In question number 30, we can see the reaction. What is the reaction when PCl3 reacts with water? You can always remember that, my dear students, you can always remember that when PCl3 is reacts with water. Here, I give you a small trick. When this PCl3, you can get the plus 3 oxidation state. You can determine it x minus 3, that equal to 0. So, x is equal to plus 3. So, my dear students, a plus 3 oxidation state present in phosphorus. When it reacts with water, 3 molecules of water, to form same oxidation number compound, and that is the S3PO3 plus thrice Hc. My dear students, this is called orthophosphorus acid. Here this is the orthophosphorus acid, and in this orthophosphorus acid you can get the plus oxidation state. Here 3 plus X minus 6 is equal to 0. So, you can get the 3 plus X that equal to 6, and you can get here X is equal to 6 minus 3 that equal to plus 3. So, my dear students, you can get the plus 3 oxidation state. It means when in reactant, when plus 3 oxidation state reactant is present, then product is also obtained by the plus 3. This is the important point, and this is a trick. Because, my dear students, when we see the second reaction, this is the second reaction, first reaction this, and when you can see the second reaction, when this PCl5, which plus 5 oxidation state of phosphorus is present, reacts with water to form, my dear students, S3PO4, means PCl5 plus 5 oxidation state phosphorus obtain plus 5 oxidation state of S3PO4, and my dear students, plus this HCl is removed. So, you can see here plus 5 oxidation state phosphorus reacts with, this is a reactant, reacts with water or other compound to form, my dear students, here plus 5 oxidation state here product. So, plus 5 oxidation state reactant to get plus 5 oxidation state product. So, my dear students, here you can see the answer. PCl3 reacts with water to form S3PO3 and HCl. So, you can go the option B, question number 30. Option is your B, my dear students, S3PO3 and HCl. Now, we can go the question number 31. Here you can see the question number 31, my dear students. Which of the following oxacids of phosphorus has strongest reducing agent? What is the concept? Concept is that reducing agent are itself oxidized and reduces another elements or another compounds. When these reducing agents are itself oxidizes. So, my dear students, when you can see this is a reducing agent strongest. So, you can see lower oxidation number oxides act as a strong reducing agent. Lower oxidation number oxides, lower oxidation number oxides or oxacids or act as strong reducing agent. Lower oxidation number oxides or oxacids are act as strong reducing agent. So, here my dear students, you can see the oxidation number of phosphorus. Here you can calculate the oxidation number of phosphorus. You can calculate, my dear students. Here H4P2O7, in H4P2O7, in A option H4P2O7, you can get the 4 plus 2x minus 14 is equal to 0. Then 2x is equal to 14 minus 4, that equal to 10. Means 2x is equal to 10, then x is equal to plus 5. Here H4PO7 you can get the plus 5 oxidation state. Now we can determine the oxidation state of H3PO3. Here 3 plus x minus 6 is equal to 0. Then you can get the x that equal to plus 3 oxidation state present in H3PO3. Now we can go the C option. H3PO2, 3 plus x minus 4 is equal to 0. Then x is equal to, you can get plus 1. So here oxidation state is plus 1. Here if you go the H3PO4, 3 plus x minus 8 is equal to 0. Then my dear students, x is equal to plus 5. Here you can go the oxidation state plus 5. So my dear students, you can see plus 1 oxidation state may be higher, plus 3 or plus 5. Then plus 3 oxidation state may be higher than go to plus 5 oxidation state. But my dear students, you can see here plus 5 oxidation state is not go to higher oxidation state. So my dear students, H3PO2 is all itself oxidized. Those reagents, reducing agents are itself oxidized. Those compounds which are itself oxidized are act as a reducing agent or strong reducing agents. So we can go to the option C, and 31 answer is your C is the correct answer. This question is also asked in NEET 2019 Odisha exam. Now my dear students, we can go to the question number 32. Here we can see which is the correct statement for the given acids, phosphinic acid and phosphonic acid. Now my dear students, concept is that phosphinic acid. What is a phosphinic acid? First of all, you can see the phosphonic acid. My dear students, phosphonic acid is the H3PO2. And my dear student, phosphonic acid is the one oxygen atom is greater, that is H3PO3. Now when we draw the structure of H3PO2. My dear students, it's a very simple method. You can one oxygen atom go to the phosphorus attached. Here number of oxygen atom is present as OH ions. This is a OH radical. And here remaining hydrogen atom, if you have more than one, then it is directly attached with this phosphorus. So my dear students, here you can see H3PO2, one OH group is present. Now we can see the H3PO3 phosphonic acid. Here in phosphonic acid, my dear students, P double bond O, one oxygen atom is attached with this phosphorus. Another oxygen and hydrogen are present in the form of OH group. So you can see here 2 OH group is present in phosphonic acid. When 2 OH group are present in phosphonic acid, that's why it's a dibasic acid. And when one OH group is present in this H3PO2, then it is called monobasic acid. In this way, my dear students, we can see here phosphonic and phosphonic acid. Here this is the monoprotic acid and it is a diprotic acid. Monoprotic acid means only one OH group is present, and a diprotic acid means here you can see the 2 OH groups. So my dear students, your answer is A. Question number 32, answer is your A. Now we can see here, this question is also asked in NEET 2016, and this is the concept. Now my dear students, we can see here question number 33. In question number 33, strong reducing behavior of H3PO2 is due to First of all, you draw the structure of S3PO2. We draw the structure in question number 32. So, PO, OH, H and H. Here, my dear students, you can see here presence of one OH group and two pH group. Presence of two pH group. This compound make strong reducing behavior of S3PO2. So, your answer is D, because oxidation state of this compound is +1 and oxidation state of this compound is +1 due to attached of formation of bond between phosphorus and hydrogen. My dear student, this question is also asked in 2015. Now we can go to the question number 34. Here, my dear students, when we go to the question number 34, which of the following statement is not valid? Means wrong statement about this oxides of phosphorus. Orthophosphoric acid is used in the manufacture of triple superphosphate. Yes, my dear students, S3PO4 is called orthophosphoric acid. It is always used in triple superphosphate in fertilizer. Hypophosphorus acid, my dear students, is a diprotic acid, and in question number 33, question number 32, you can see the structure of hypophosphorus acid, and it is the S3PO2. This S3PO2 is called hypophosphorus acid, and in this structure you can see here only one OH group is present. And we can know that number of OH group, this is a concept, my dear students. Here you can see the concept and structure. Number of OH groups is proportional to the here acidity. Here, because here only one OH group is present, you see here only one OH group is present. So, my dear students, due to this one OH group, it is a monobasic acid, not dibasic acid or diprotic acid. So, question number 34, my dear students, answer is your B. Hypophosphorus acid is a diprotic acid. Now, we can go to the question number 35. Oxidation states of phosphorus in H4, P2O5, H4P2O6 and H4P2O7 are. My dear students, you determine this. H4P2O5, 4 plus, this is a 4 oxidation state of this hydrogen, 2x minus 10, that equal to 0. So, my dear students, you can say here 4, here 2x is equal to 10 minus 4, that equal to plus 6, and here x is equal to plus 3. So, in H4P2O5 you can get the plus 3 oxidation state. Now, we can determine the oxidation state of H4P2O6. 4 for hydrogen, phosphorus oxidation state is determined 2x minus 12 is equal to 0. So, my dear students, 2x is equal to 12 minus 4, then x is equal to 12 minus 4 means 8 and x is equal to 4. H4P2O6 you can get the plus 4 oxidation state, then here you can obviously get the plus 5 because here 3, 4, 5 are present. Now, my dear students, so your answer is 35D answer is correct answer, because we can determine the oxidation state by in these methods. Here I give you these methods and you can easily calculate it. So, question number 35 answer is D, and this question is also come in NEET 2010. Now, my dear students, we can see here question number 36. Here question number 36, how many bridging oxygen atoms are present in P4O10? It means you may know the structure of P410. When you know the structure of P410, you can determine the bridging oxygen atoms are present. My dear students, you see the structure of P410. One oxygen atom is always attached with this phosphorus, and phosphorus are not directly attached. Here this oxygen is attached, then phosphorus, then this phosphorus attached with this oxygen, then oxygen in ring, then phosphorus, because we made the one ring cyclic structure. Here you can see the oxygen, then this is the phosphorus. Now here we can write the phosphorus in center, but these oxygen atoms are present between the phosphorus. So my dear students, you can see here 3 bridge oxygen atoms are present here. You can see here 3 bridge oxygen, and here 1, 2, 3 are present. So you can say here 6 oxygen atoms are present as a bridging oxygen. So this is the question number 36. Answer is A. This question is also as in MENT 2010. Now my dear friends, we can see here the structural formula of hypophosphorus acid. We can make in question number 35, 36. So you can easily know this is the structure. Formula is S3PO2. So when molecular formula of this hypophosphorus acid, molecular formula of hypophosphorus acid, phosphorus acid is S3PO2. So my dear students, you can see the structure here, S3, 1, 2, 3, S3PO2. So my dear students, you can go the question number 37. Answer is, that is C. Now my dear students, we can go the question number 38. In question number 38, S3PO2 is the molecular formula of an acid of phosphorus. The name and basicity respectively are. Now we can see here in neat paper, S3PO2 is a very important reagent at that time, 1992, 1993 or 1996, 1997. And this is called hypophosphorus acid. In this hypophosphorus acid, this is name of hypophosphorus acid, and this hypophosphorus acid only one OH group is present, and one OH group is present means it is a monobasic acid. So you can go to the question number 38, option is C. Now my dear students, question number 39. Which one of the following substance is used in the laboratory for fast drying of neutral gases? Here it is a simple question which is asked in our theory, and answer is, this is phosphorus pentoxide, means P2O5. P2O5 is always used as a drying agent or drying reagent in your laboratory. Now my dear students, we can go to the question number 40. P2O5 is heated with water to give. My dear students, it's a basic reaction. When P2O5 is heated with water, then my dear students, you can get the S3PO4. Why? Because my dear students, you can calculate the oxidation state of phosphorus. Here +5 oxidation state is present in reactant. So here +5 oxidation state, oxoacids are formed. So you can easily find out P2O5 get the S3PO4, and this S3PO4, my dear students, are called ortho phosphoric acid. This H3PO4 is called orthophosphoric acid. So my dear students, you can see here question number 40, answer is D. H2O5 plus water and you can get the orthophosphoric acid. 2 and here thrice. Now my dear students, we can see the question number 41. Basicity of orthophosphoric acid is, first of all, you can see the orthophosphoric acid structure, molecular form is H3PO4. Then you can make the structure. Phosphorus, oxygen are directly attached with phosphorus and remaining oxygen and hydrogen are present in the form of OH. So here you can see the 3 OH groups are present. When my dear students, in oxoacids of phosphorus, 3 OH groups are present, it means basicity of this is 3. 3 OH groups. So basicity that equal to 3. Now my dear students, here we can go to the question number 42. When orthophosphoric acid is heated to 600 degrees Celsius, the product formed is orthophosphoric acid, my dear students, that is H3PO4, and when heated up to 600 degrees Celsius, here H2O is evolved, and when this H2 is removed, remaining part you can get HPO3, and this HPO3 is called metaphosphoric acid. So my dear students, here you can see the metaphosphoric acid you can get when H3PO4 is heated at high temperature, that is 600 degree Celsius. It is called orthophosphoric acid. So my dear students, when orthophosphoric acid is heated at 600 degrees Celsius to give metaphosphoric acid. Now we can see here question number 43, which is the correct thermal stability order for H2E. My dear students, here when we move 16 groups, oxygen, sulfur, selenium, tellurium and polonium. Here you can see the atomic size increases also, and when atomic size increases, and these are formed hydrides H2O, H2S, H2Se, H2Te and H2PO. When size is greater, bond distance is maximum, so this hydrogen is easily broken from these hydrides. So my dear students, size is increases, so thermal stability of water is highest, and you can see this is answer is D, because in D you can get the highest thermal stability H2O, H2S, H2Se, H2T, H2PO. And this question is also asked in, my dear students, NEET 2019. Now we can discuss the question number 44. Acidity of diprotic acid in aqueous solution increase in the order. Now you can see the 16 questions: sulfur, selenium and tellurium. My dear students, here atomic size is increases top to bottom. If atomic size is increases, then it form H2S. Here it's form H2Se. Here it's form H2T. So my dear students, when atomic size is increases, so this hydrogen is easily broken. So when this hydrogen, this compound easily gives H plus ions, it means it's a strong acid. Acidity, so my dear students, it is increases, H2T more acidic than H2SC and H2S. So my dear students, you can go to the option A with a question number 44. And this question is also asked in 2014. Now my dear students, we can see here question number 45. Which of the following bonds has the highest energy? Here, my dear students, oxygen, sulfur, selenium and tellurium. 16 group you know, and when you can move the top to bottom, atomic size is increases. When we move top to bottom, atomic size is increases, and when atomic size is increases, it means bond energy is lower. Bond energy is lower. But except in this oxygen, my dear students, sulfur has a highest energy. So, my dear students, sulfur has the highest energy in single bond. In single bond, in a covalent bond. So, sulfur forms S8, and it's also shows as, it is also called as catenation property. So, my dear students, S8 show the catenation property here. These are the questions, my dear students, and I give you explanation with concept. In all questions, I give you concept, I give you structures, I give you theory also, and now I hope you learn very well, my dear students. Thank you very much.